Hi, good morning, my dear students. I'm Daphne Call. Welcome to my discussions. Today we will discuss about electrolysis. At first, we will discuss about the similarity and differences between the voltaic cell and electrolytic cell. After that, we will use the theory of Faraday's first law of electrolysis to determine the mass of substance deposited at the electrodes. Electrolysis is the use of electric current to stimulate a non-spontaneous chemical reactions. Now, let's start our discussions today. At first, we will discuss about the similarity and the differences between the voltaic cell and electrolytic cells.
An electrochemical cell is a device capable of either generating electrical energy from chemical reactions or using electrical energy to cause chemical reactions. The two types of electrochemical cells are voltaic cell and electrolytic cells. Electrolysis is carried out in an electrolytic cell, which consists of an electrolyte, two electrodes, and the power supply, which is direct current. Now, let's look at the similarity and the differences between the voltaic cell and electrolytic cell. A voltaic cell is an electrochemical cell that uses chemical reactions to produce electrical energy, while an electrolytic cell converts electrical energy into chemical energy. For voltaic cell, it does not require external voltage source and spontaneous reactions occurs. However, for electrolytic cell, it does require external voltage source and the non-spontaneous reactions occurs. My dear students, always remember if for voltaic cell, the anode is negative terminal and the cathode is positive terminal. However, for electrolytic cell, the anode is positive terminal and the cathode is negative terminals. Now, let's look at the similarity of voltaic cell and electrolytic cells. Always remember that both are electrochemical cells and the redox reaction takes place in both cells. And both cells contain anode and cathode, where oxidation takes place at anode and reduction at cathode. So, my dear students, these are the differences and similarity between the voltaic cell and electrolytic cell. Now, let's go to the part of Faraday's law of electrolysis. Faraday's law of electrolysis shows the quantitative relationship between the substance deposited at electrode and the quantity of electric charge or electricity passed through the electrolyte. Other than that, we can use this law to calculate the amount of substance produced during electrolysis based on the amount of current passed through the electrolyte. Now, let's look at the Faraday's first law of electrolysis. It is one of the primary laws of electrolysis. It states that the amount of substance produced at each electrode is directly proportional to the quantity of charge flowing through the cell. Therefore, the formula of the amount of electrical charge in column is equal to current times times. Next, the amount or the quantity of electricity can also be expressed by the Faraday unit. Therefore, the relationship between the Faraday constant and the Avogadro constant is like this. where L is Avogadro constant and the E is the charge of one electron. For exam purposes, the value of the Faraday constant is usually taken as 96500 coulomb per mole. So 96500 coulomb is called 1 Faraday. So my dear student, as a conclusion, here are the equations that we discussed just now, and we are going to use this equation to answer the questions in example 1. A current of 5 ampere is passed through an aqueous copper sulfate for 4 hours using copper electrodes. Calculate the mass of copper deposited at the cathode. At first, write down the information given from the questions and convert the unit of times into second. Then determine the half ionic equations at the anode and cathode. Then we need to determine the quantity of electricity in coulomb. By using Faraday law, we have this formula. Therefore, the quantity of electricity is 7200 coulomb. For second step, we need to write down the half ionic equations to determine the number of mole of copper deposited at the cathode. Before we determine the number of mole of copper deposited, we need to know the number of mole of electron produced by 7200 coulomb. As we know, 1 Faraday is the amount of electric charge carried by 1 mole of electron, and 1 Faraday is 96500 coulomb per mole. Then when there is 7200 coulomb of electric charge, so the number of mole of electron produced is 0.746 mole. Now let's come back to the half ionic equations at cathode. From the half ionic equations, there are 2 mole of electron needed to deposit 1 mole of copper, and there is a 1:2 ratio between electron and copper deposited. Therefore, 0.746 mole of electron will deposit 0.373 mole of copper. Now, by using the formula, the mass of copper deposited is equal to 23.69 gram. My dear student, this is the questions in example 2. Try to answer and write down your answer in the comment column. I will check for you. That's all for today's discussions.